My name is Dr. Marissa May, and in this video, I'm going to be answering some frequently asked questions I get from students about the elements of math. We are going to be using the prime factorization tool that I shared with factor trees. Now, if you missed that video, I'll be sure and link it in the cards above. That way you can take a look at it. But we're going to use it to simplify this expression. So what I want to do here is let's just recap our prime numbers we had previously written down. Those are always nice to have just kind of listed here, and you don't need all of them, but having a few of them makes it a lot easier. You don't have to think about them. Next, let's go ahead and do the prime factorization of each of these numbers. So I'll do 20. So 20 is 2 times 10. So 2 is a prime number, so I'll work with 10. That's 2 times 5, and those are both prime numbers as well. So the prime factorization of 20 is 2 to the second times 5. Then let's do 45, and 45 was 3 and 15, and 3 was prime, and 15 was 3 and 5, both of which are prime as well. So I get 3 to the second times 5. Okay, now that we've done our prime factorizations for each of these, let's substitute them in for each of the numbers. So in place of 20 to the third, I'm going to do 2 to the second times 5 to the third power. Okay, now in place of 45 to the fourth, I'm going to put 3 to the second times 5 to the fourth. Now, remember our rule about exponents? When we raise a power to a power, we can multiply those exponents. So that gives me 2 to the 2 times 3 times 5 to the 1 times 3. Big times in the middle. Now I've got 3 to the 2 times 4. And then I've got 5 to the 1 times 4. Okay, now we'll go ahead and multiply these exponents. That gives you 2 to the 6th times 5 to the 3rd times 3 to the 8th times 5 to the 4th. Now, I see I have 5s, right? 5 to the 3rd, 5 to the 4th. When we multiply, we add exponents. So 2 to the 6th stays the same. 3 to the 8th stays the same. But 5 becomes 5 to the 3 plus 4, which gives me 7. And now I have reduced my original problem down to its prime factorization, which notice the 2, the 3, and the 5 are all prime numbers. So I know that I'm done.